Welcome to the engineering class for November the 12th. Okay, so sorry I wasn't able to be here last time, but I had something else I had to do. And I see that you guys clearly figured things out. I see that you have done the assignment that I asked you to do, and most of you got a perfect score on it. The code that you submitted for the that task that I asked you to do, um, some of you did the code in you did the job in just a few lines of code. Others of you used up a lot more code, but you got the job done. And so although I did ask you to do it in as few lines as possible, I decided that, yeah, I'll be a little lenient here. So as long as you got the job done, I gave you full credit. Even though you may have used more lines of code than you could have, hey, you got the job done. So I'll give you credit for that. Okay, and then the other assignment that was due last time that we met, or last time that we would have met had we met, it looks like you guys got that one pretty well too. Let me just throw it open for questions. Do any of you have any questions about either of those two assignments? Either the one that was due on Tuesday or the one that was due today? What is a microbit? Okay, a microbit is a thing that's like an Arduino. It's not as commonly used as Arduinos are. Yeah, it is. It is brand new. Our Tinkercad just barely added it. It's basically just another version of Arduino. But I'm going to stick with Arduino because Arduinos are far more commonly used. Pretty much everybody in the world uses Arduinos. And so you guys are actually good. It's good for you to learn Arduinos because when you get out into the real world, if you go to apply for a job and they ask you, yeah, do you know how to use an Arduino? And you say, what's an Arduino? Not going to be good. But if you say, oh, yeah, I know Arduinos, I've used Arduinos a lot, give you a good head start. Okay, no other questions. All righty. Well, let's start into the material for today. Okay, so what I'm going to do today is give you an assignment to do something useful with the Arduino. So you are going to need to use both your electrical engineering skills, which you are now pretty good at, and also you're going to need to use your computer engineering skills. It's been a couple of weeks since we did that, but you're going to bring the two of them together and you're going to make an Arduino board that does something useful. It's still pretty simple. We'll get a little more complicated later. Okay, so rather than me telling you in words what I want you to do, let me show you a demo of what I want you to do. Okay, so if we go to the engineering technology Canvas page and go into modules, you'll see that we have a new assignment now, which will be new next time we meet. And so this is Arduino input and output. So input to the Arduino, that's the new thing that we're doing today that up until now we have not done. Well, up until now, we've always used the Arduino to output something, either to turn on a light or turn on a buzzer or something, but we've never input stuff to the Arduino. The Arduino primer that you guys read last time on Tuesday, that talked about how to do it, but today let's actually do it. Okay, so if you click on here, then you'll see something here. It says, I want you to use Arduino or use the Tinkercad to create an Arduino-based thing that meets the following functional specification. All right, so this right here is the functional specification, but rather than read it to you, let me just demonstrate it to you. Okay, so what we've got is we've got an Arduino that is connected up to some device. Okay, so this thing that you see that I'm moving around right now, okay, that's a special kind of thing called a power supply. You can think of it as if it's a battery where you can just turn a knob to adjust the voltage. And this is only something that we're going to use for testing our creation out. Once we get our creation going, we're going to use the Arduino to measure the voltage on things like You know, we've got this nifty little lemon battery here, and we've got other things that we could use. So those are the things we're actually going to test it on. But we're just going to use this thing to help us get started. All right, so the idea here is that we are going to connect the voltage output from this device or whatever it is we're connecting into some pins that up until now we have not used before. So let's take a look at these pins here. All right, so one of them says GND. So that just means that's just like the negative side of the Arduino battery. So that's ground. So that one's not really important, but well, I should be careful. If you don't connect it up, it won't work. So it's important in that regard. But okay, so the trick here is we've got some pins here. These are called the analog input pins. And so these are new. We've never used them before. Now, in the homework that you guys turned in just today, one of the questions was, what's the difference between analog and binary? And you all pretty well got it right. So you know that analog is a voltage signal that could be anything. You know, it is not just full on or full off, but it could be somewhere in between. It might be 1.1 volts. It might be 2.7 volts. It might be, you know, whatever. Whereas if we go up at the top here, let me go. Okay, so these pins along the top here that we've been using a lot up until now, these are digital I/O pins. So I/O stands for input output. So we've been using them only for output, but we could use them for input too. But because they're digital, they work, you either get full voltage or no voltage, there's nothing in between. And so if you're using it as an input, then what happens is the Arduino looks to see, is there voltage on the pin or is there not? And you come back with either a 1 or a 0. Now, the 1 does not mean that the voltage is 1 volt. It just means there is voltage. So what happens is there's a threshold. And so if the voltage on that pin is anything above the threshold, then you get a digital 1. If it's anything below the threshold, you get a digital 0. Okay. But that's not what we want today. We want to be able to read analog voltages. And then we want the Arduino to respond depending on what the analog input is. Okay, so we'll be using these for the first time today. And we're going to be getting our input from this power supply, which is basically just think of it as a battery with a knob on it, so I can adjust the voltage. Okay, and then what's going to happen up here is let me slide it up here just so that you can, I want to be able to see this zoomed in here. Okay, so you are going to make a device that reads the analog voltage, and if the voltage is anywhere between 0 and 1 volt, then you're going to have one LED come on. If, on the other hand, you've got somewhere between 1 and 2 volts, then you're going to get 2 LEDs come on. So let's actually see it. Okay, so let me start the simulation. Okay, so right now we have 5 volts, which is a special case. Let's hold off on that. Okay, so did you see how I do that? I grab onto this knob here and I just turn the knob. Okay, so I've set it now for 0 and you see that there's no lights on. Okay, so if I turn the knob just a little bit, so we've got 600 millivolts. So that means 0.6 volts. You see I've got one light on. Okay, so, but just by looking at the lights, I know that the input voltage is somewhere between 0 and 1. Okay, so now let's kick up the voltage a little bit. Let's take it up. Okay, so 1.4. So you see now I've got 2 lights on. All right, now if I take it up to 1 point or a little bit more, 1.6, I still only have 2 lights on. Okay, and now let's take it up to, okay, so it's kind of hard to get exactly the voltage I want. Okay, so when I go up about 2 volts, then I get another light coming on. Let's go up above 3 volts. Okay, so I get another light coming on. Now, if I go up, so I'm somewhere in the range between 4 and 5 volts. Now I have all of my lights on. Okay, so this is a potentially useful device. So that, you know, if I don't really care exactly how many volts it is, I just want to know approximately how many volts it is. I can just look at the lights, and by seeing how many lights are on, I can know what the voltage is. Now, Let's take it up above 5 volts and see what happens. Okay, you see how all the lights are flashing now? That's intended to be a warning, because we have to be careful with Arduinos. If we try to put too much voltage into our Arduino, we can destroy the Arduino. And I tell you that that's not just a hypothetical, that's real. This is an Arduino. If we were meeting face-to-face at the school right now, I would lend all of you guys an Arduino. I have enough Arduinos. I have one that everybody can have their own Arduino, not to keep, obviously, but I lend it to you. But we do have to be careful, because in the past, students have destroyed my Arduinos. What they've done is they've plugged in voltage into the input pins there, where they put in too much volts and it destroys the Arduino. Now, Arduinos are not super expensive, but still they do cost money. And so I do get grumpy when students destroy my Arduinos. And so this is the beautiful thing about this software package that we have here, is that we can put in too much voltage and destroy our Arduino, but it's like when you get killed when you're playing a video game, right? You just restart the game and you come back to life. So that's the really nice thing here. So if I start my simulation going with my power supply, if I wanted to, I could crank this baby all the way up to 30 volts. So if this was a real Arduino and I had 30 volts plugged into my input there, then I would for sure destroy that Arduino. But it's a software Arduino. That's all right. We'll just restart the software and we get a new life going on our Arduino. Okay. So now, so your job then is going to be to write the code that allows the Arduino to read the input and then turn on the right number of lights depending on how much voltage we have. Okay. All right. So now a couple things. One is when we turn on the light, these resistors here are important. And when we first looked at Arduinos, you guys didn't understand about resistance. We hadn't talked about that. And so you may not have really known why they were there. But now we can talk about them. Now that you guys know about resistors. Okay, so tell you what, let's turn on the simulator. And you see the resistor, the lights are on and they're nice and bright. What if I wasn't using a resistor? So let's take this resistor and let's just kind of set them aside here. And let's just go ahead and wire this in directly to the ground here. Let's see. Okay. So, all right, so let's trace the path here. What's going to happen. So when I turn on pin 11, let's see how the electricity is going to flow. All right, so when pin 11 is turned on, electricity is going to flow through here and is going to come into the breadboard. And anything that's connected in these 5 dots here, if I connect something to this dot, it's connected to everything there. So when I connect this wire here, all of these dots now, it's like they are all directly connected to pin 11. So they are all going to have voltage on them. So what's going to happen is the electricity can come in here, flow through here. It flows through the LED, comes back, comes to here, flows over to here. Now all of these lines right here, these guys are all connected together, kind of the same way that these guys are all connected together. Except down here, instead of having just 5, I've got a whole line there. Right. So when the electricity comes in through here, goes into here, come back here, go to ground. So you can see I have a complete path here that it can go. But the only thing that I have in the path is the LED. So let's see what happens if I try to light this thing up when I don't have a resistor in there. So when I start my simulation, you see that little exclamation mark right here. Okay, that is warning me that I am destroying my my LED. And in fact, if I come over and hover over here, you can see a note here that says It says that the current through the LED is 53 milliamps, which is too much. The recommended maximum is only 20 milliamps. So the usable life of the LED may be reduced. Okay, so this is warning me that I'm destroying my LED. So what I need to do is I need to put in a resistor in order to make it so that we don't get so much flowing through there. All right, so let me take that wire and get rid of that. And let's take my resistor. And so if I put my resistor right here like that, so it's connecting this terminal here and this terminal there, so the electricity flows. And you see I've got a 100 ohm resistor. Okay, so that now makes it so that the light comes on and it's nice and bright, and I don't get that little warning message. What if I were to change that value of that resistor? Let's say that instead of 100 ohms, let's say that I use 100 kilo ohms. So that means I've got 100,000 ohms. Okay, you see what happens? It looks like my LED is off. Now, if you look really closely, you can see it actually is glowing a little bit, just not as much as it should. I've got so much resistance that I'm not getting enough current through there to light up my LED. Okay, so let's go back to ohms, and that's good. Okay, so what if I tried 150 ohms? What would that look like? Okay, so there you go. So that's not bad. You see that the resistance there, it's this LED, if I don't really see any noticeable difference there between this LED and that LED. So I could use a 100 ohm resistor or a 150 ohm resistor, that'd be fine. What if I tried a 500 ohm resistor? Okay, all right, now I can definitely see a difference. That LED on the left there here, he's definitely not as bright as he used to be, all right? What if I try going the other direction? Let's say I put in a 50 ohm resistor, okay? Oh, I'm getting the little warning sign, okay? So that's telling me that the current that's flowing through my LED there is too high. So I'm in danger of destroying my LED. So I'm okay with you guys just playing around with this rather than actually calculating it. But just, play around. So what I've found is that if I use 100 ohm resistors, that seems to work really well. I get the LEDs nice and bright, okay? So just make sure that you use resistors, and please use a breadboard here. I want you guys to get used to breadboards and how they work. So remember that the key to a breadboard is that anything that is plugged in to any one of these 5 holes is connected to each other. So this is exactly the same as if I had a wire connecting that LED directly to that resistor, because underneath the breadboard, if you look inside the breadboard, that is in fact exactly what's happening, right? But each one of these groups of 5 here is independent. That group of 5 is different from this group of 5, different from this group of 5. They're all independent. Whereas down here, this entire row is all connected together. And then this row right here is a different row. All of those are connected to each other, but they are different from that row. So that's the way the breadboards work. Okay, so now here is the key, is we need to learn something new about programming, something that we have not yet done. We need to learn how to write a program that will recognize input. So I need to tell the Arduino to look on pin A0 and then do something different depending on what the voltage is that it sees on pin A0. So let's go in and take a look at the code that I've got. So I'm using the drag and drop code. And so I've got a new line here. So let me just do this one at a time. So let's just look at this guy alone. So this is a command that we have not used before. And so what I've done here, so these are the commands we've used before, the output commands, the input commands, the control commands, those are things we've used before. But if you look under variables, you'll see a bunch of things that were new before. Now, when you first do this for the first time, in fact, tell you what, let me open up a brand new one that because I want you guys to see what it looks like when you open one up for the very first time. Okay, so let's go back to Tinkercad here, and let's create a new circuit completely from scratch. Okay, so I'm going to create a new circuit. And I'm going to pull in an Arduino. Okay, and now I'm going to look at the code. So the default code just blinks the built-in LED. All right, so that's not what I want to do. So I'm just going to drag all that right straight to the trash. I don't want that. Okay, so now let's click on variables, and you'll see that there are no variables in there right now. So when we looked at the code that I had, you saw there were some variables. I was the one that created those variables. So if you click on this thing right here, it says create variable. It asks you, okay, what name would you like that variable to be? So you could just give it a simple name like X. And so when you do that, you see that we now have an object that we can drag in here, and you'll see in a minute how that works. Okay, but we also have a couple of things that we can drag in here that says set X to something. All right. And then if we wanted, we could also have another variables. Let's say we want to have another variable called Y. Okay, fine. So now we have a variable called Y, right? Now, remember that this variable name is just a holder. So like what we could do is we could drag this over here, and we could say set X to 5. Okay, so when we run the program, it's going to take the number 5, and it's going to store that as X. And so then later on in the program, if we were to say, what is X? Then it'll say X is 5. Or if we were to say, I want you to turn on pin X. And so it'll say, okay, well, let's see, what is X? X is 5, and say, okay, turn on pin 5. So it's very, very useful here. Okay, but what I want to do is I don't want to decide what the number is that got stored in X. I want the Arduino to look on the analog pin. Okay, so remember, so these are the pins here. So you can see I've got 6 different pins that I can use. I've got pin A0, A1, A2, A3, A4, and A5. So I've got 6 different pins. So what I want the Arduino to do is to look on one of those pins and see what voltage is on that pin. And then it'll take that number and it'll store that number as X. All right, so how do I do that? Well, if I'm going to read input, that sounds to me like it's an input command. So let's go up here and let's click on input and see what we got. And you'll see that one of our little blocks here says read analog pin, whatever. So if I drag this over and I put it inside that oblong there where it used to say 5, okay, so now it's going to read the voltage on analog pin A0, and whatever that is, it's going to set that as X. Now, if I wanted, I could tell it to set it as Y, okay, but I don't. I want to call it X. Now you'll see that I don't have to do pin A0. I can do A1, A2, A3, A4, or A5. Let's just stick with A0. Okay, so we're going to read the voltage that we see on pin A0. Now, what are we going to do with it? Well, the first thing that I'd like to do, just to get you familiar with how to do it, is I want to see what number the Arduino sees. So we're going to do something else that we haven't done before. There's this thing called the serial monitor. You may have noticed at the bottom of the thing here. Well, let's use that for the first time. Okay, so what I'm going to do here, let's go to output. And you'll see that one of our outputs here that we've never played with before is it says print to serial monitor. Okay, so what I'm going to do is I'm going to do the first step, and then I'm going to print something on the serial monitor. Now, I don't want to print the words hello world on the serial monitor. What I want to do is I want to print what is the value of X. I want to put that on the serial monitor. Now, this with and without new line. Okay, all that means is that after it prints the number, Do you want it to then jump down to the next line, or do you want to just put all of the numbers on the same line? So I kind of like the idea of jumping down to the next line here. Okay, so I think we're ready. Now, it probably wouldn't be a bad idea to put a little wait statement in here, because the Arduino, it goes through these cycles really fast, and probably too fast. So let's tell it to wait for maybe a half a second. So 0.5 seconds. Okay. All right. So I think we've got some good code here. So right now, all it's going to do is read the voltage and then print it out on the serial monitor. It's not going to turn on any lights or anything. So, oh, we don't have any voltage to put on here. We better get some voltage to put on here. So let's go down and let's find this thing that's called a power supply. It's that variable battery that I was telling you about. So it's right here. Okay, so this is a power supply. It's a battery where I can control the voltage. All right, so I better hook it up to my Arduino. So this black one here is the one that has to be connected up to the ground. And I like to make my wires black. This is just something that all electrical engineers do, is if anything that's connected to ground, we always make the wire black, just so we can tell at a glance, well, that's the wire that's connected to ground. Okay, so this other one here, let's come in here and let's connect that one into my A0 pin. Okay, and the color on that one isn't really important, but I'm going to make it red just because usually that's the way, because this terminal I've got it plugged into here is red. Okay, so when I start my simulation, then I've got some voltage now, and I can change this voltage to be whatever I want. Now it's kind of hard when you're twisting the knob here, it's kind of hard to get it exactly where you want. So there's a really neat trick you can do. If you just click on this, it gives you this little box where I can type in the voltage. So if I want 1.2 volts, I get exactly 1.2 volts. Now there is a little bit of a catch here. If I wanted 1.3 volts, you'll see I don't get 1.3 volts. The software here is limited. It can only go in steps of 0.2. So if I want 1.6, great. If I want 1.7, not so great. It gives me 1.8, but that's okay. I can handle that. Okay, so what I'm going to do is I'm going to set it for 1 volt. And you can see that on the power supply, it reads it as 1,000 millivolts, but that's the same thing. 1,000 millivolts is 1 volt, same thing. Okay, so my Arduino now is running. It's reading the voltage. And you'll remember that what I told it to do was to print the voltage on this thing called the serial monitor. So I look around and I say, I'm not seeing any serial monitor. Well, here's what you have to do. If you click on the code, and then down at the bottom, you get this thing called serial monitor. And you'll see there's a bunch of numbers right there. Okay, so, and it looks like those numbers are just sitting there not really doing anything. But if I change my value here, you see how the numbers change. Okay, now it's a 0. So 0 volts here corresponds to 0 there. Okay, so let's take it back, and I want it to be 1 volt. And so let's see if the Arduino reads that as being 1 volt. Uh-oh, we got a problem. The Arduino does not read it as being 1 volt. So it's kind of like a unit conversion. It's kind of like when you convert from centimeters into inches. The number that the Arduino reports is always going to be the number of volts times some internal factor, which in this case turns out to be 205. Okay, so in your notebooks, because I know you all take careful notes, right? I want you to open up your notebooks and I want you to write, okay, so if the Arduino is seeing 1 volt on the analog input pin, the number it reports is not 1. The number it reports is 205. Okay, so 205 Arduino units is equal to 1 volt. Now, what do you suppose I would get if I kick it up to 2 volts? Okay, so can you guys type into the chat box? if I were to change the voltage on my power supply to 2 volts, what number would the Arduino? Okay, 410. All right, sounds good. All right, let's go ahead and see if that works. So I'm going to kick it up to 2 volts, and you'll see that I get a number that's almost 410, but not exactly. Okay, so there's just a little bit of round off here. Don't worry about that. It's a number that's close enough to 410 that we can call it 410. All right, and so then if I go to 3 volts, then I should get something that's approximately equal to 3 times 205. And you see, yep. So you would have expected to get 615, but 614, yeah, it's just round off error, basically, is all that's happening. Okay, so if I go to 4 volts, okay, it goes up to 818. If I go to 5 volts, it goes up to 1023. Now, pay close attention here. Let's see what happens if I go above 5 volts. What happens if I go to 6 volts? Doesn't change. Okay. So the Arduino can only read up to 5 volts. If you try to go above 5 volts on your input, okay, so first of all, the Arduino is not going to recognize it as being anything above 5 volts because 5 volts is the most that can happen. But more importantly is you risk damaging the Arduino if you ever hook anything up to it that's more than 5 volts. Okay. So as long as you stay under 5 volts, so let's say you could put 4.2 volts in there. Okay, so you see this number here, right? So what you need to do then is you need to write some code so that depending on what this number is, that determines how many lights the Arduino is going to get turned on. Okay, so let's go back here to my original circuit. So this is the circuit that I expect you guys to build. And so I've called it the voltage reader circuit. So let's go in here and I'm going to tinker that. Okay. Boy, Tinkercad sometimes is really slow. Okay, there it goes. All right. And let's get rid of that. I don't care about that. Okay. All right. So let's just turn it on, remind ourselves how it works. Okay, so if the voltage is 0, I get no lights. If I turn the voltage up a little bit, I get 1 volt, 1 light or 2 lights or 3 lights or 4 lights. Okay, so how does the Arduino change how many lights it turns on? Well, let's look at the code here. Okay, so you see the first thing is this command here where I've got a variable that I didn't want to call it X because that's not a very descriptive name for the variable. So you can have your variables anything you want. You'll notice I've got one called X, one called Y. I've got one that I called Signal. I've got another one called Mr. H. I could have another one called George. Okay, you can call these variables whatever you want. So what I did was I created a variable and I called it Signal just because that kind of describes what it is that I'm doing, right? Okay, so now let's look at this piece by piece here. Okay, so the first thing that I'm going to do after I print it. Oh, actually, wait a minute. Where did I haven't read. Okay, I better not forget this guy. So the first thing I need to do is I need to read the analog pin and set it to A0. Okay, then I'm going to print it to the signal, or I'm going to print it to the serial monitor. Okay, now next thing I'm going to do is I'm going to say that if the number that is stored in signal is anything greater than 0, then I want to turn on pin 11. Okay, that makes sense. So pin 11 is the one that controls this first LED. So if I have 0 volts, I get 0 lights. But if I have any voltage at all, pin 11 is going to get turned on and that light is going to come on. Okay. All right. So and then you can see I've got an else statement here. So if the signal is not greater than 0, then it sets pin 11 to off. All right, so now what do I do next? Well, you can see I've got another if statement here. In fact, what I've got is I've got a whole bunch of if statements, just one after the other, after the other. So let's look at this other one here. So my next if statement is right here. So it says if the signal is greater than 205, so that means if I've got more than 1 volt, then in addition to turning on pin 11, I'm also going to turn on pin 9. Okay. And if it's not less than that, then I'm going to leave pin 9 on. All right, so then we come up to the next one. So if it's greater than 409, so that means if it's greater than 2 volts, then it turns on pin 7. If it's greater than 3 volts, then it turns on pin 5. If it's greater than 4 volts, then it turns on pin 3. All right, so you can see, so this is how it works. So it turns on the right number of lights depending on how much voltage it has, anywhere between 0 and 5 volts. Now, what happens if I've got exactly 5 volts, or if I've got more than 5 volts? So remember what number the Arduino reports if I put exactly 5 volts on it, or if I put any number greater than 5? The number is 1023. Okay, so what I want the Arduino to do is I want it to blink fast. If I've got 5 or more volts on there, I want it to blink in order to warn me. This says, hey, wait a minute, you got too many volts on here. Okay, so here's the way I did that. Okay, so the first thing I do is after I've turned on the correct number of lights, I wait for 0.2 seconds, and then if the signal is greater than 1022, so it means there's only one number that it could be, that then is 1023, because that's the highest number you ever get. Okay, so if the signal is 1023, then what's going to happen is going to turn off all my lights. And it's going to wait for 0.2 seconds. Okay, so my lights are going to go off. They're going to stay off for 0.2 seconds. And then what is going to happen is the Arduino is going to jump back up to the top here, and it's going to turn the lights right back on again. And then when it gets down to the bottom, it's going to turn the lights back off again. And so it's just going to keep on going on, off every 0.2 seconds. All right, so now you can see why it does what it does. So let's start the simulation again. Okay, so if I've got 2.4 volts, then I get that. If I turn the voltage up a little bit more, I get that. Turn it up a little bit more still, I get that. And if I go too high, I get them all blinking. Okay, so your job is to make this. Are you confident that you could do it? So can you type into the chat box now, say yes means that, yeah, I think I got this. I think I can do this. No means, nope, I'm still not understanding it. Please help me out. All right, and think maybe, yes, maybe is good. I appreciate the honesty, or probably. Okay, so tell you what I'm going to do right now. Oh, you want to, okay, so you want to see the first part of the code again? Okay, I can do that. All right, so here's the deal. If you guys think that you can do this, then go ahead and open up Tinkercad and start working on it, but please stay on Zoom so that if you run into problems, you can ask me for help. So don't type by into the chat box and leave yet. Stay on Zoom, keep working on this while you're on Zoom. Okay, and so I've got a request here from a student. They say they want to see the first part of the code again. So, okay, here we go. And so let me stop the simulation and open up the code. And I'll slide this over so you can see it a little bit better. And let's go up to the top part here, and I'll zoom in a bit so you can see it. Okay, is that the part of the code that you wanted to see?
Yep, thank you so much.
Okay. All right, so everybody start working on it. Stay on Zoom. And I will be here just listening. If you have any questions, I'll help you out. Otherwise, I'll sit here quietly. And I'm going to pause the recording. There's no sense in recording it if nothing's happening. Okay, it sounds like you guys are doing really well. So like I said a minute ago, in order to get credit for it, do not just give me the URL up at the top, but make sure you click on the share button and then the invite people button, and then copy the link from there. Okay, so once you do that, you guys are done. And so you can type bye into the chat box and see you later. I'll stick around because I know that some of you aren't done yet. So I'll stick around on Zoom and answer any questions you might have. I'll go ahead and stop the recording again.